This is the mole. It's basically this topic is easy if you will be taking the class from the day one. So it's interconnected basically, I can say. Mole is nothing but it's the number of particles. Particles is a general term which is used for molecule, which is used for atoms, which is used for ions. It's a general term. Generally, we can say that it's a number of particle. So it's like one dozen is equal to 12, one pair is equal to 2. In the same way, one mole is equal to 6.02 exponent 23. So if the examiner would be asking the definition of mole, so I have to write amount of substance that contains the same number of particles as in 12 grams of carbon 12. Basically, carbon is the reference. Basically, carbon is the reference, like the carbon 12. Why I'm mentioning the carbon 12? Because we have isotopes of carbon 12. We have carbon 12, we have carbon 13, we have carbon 14. So only carbon 12 we have to take, okay? It's the most abundant element, or the mass of carbon 12 is 12.0000. It's exact and accurate. So that's why it's a reference. So we will be comparing each and everything with the carbon 12. Since in the periodic table you can see the mass of carbon is 12.00 grams, so I have to mention it in the definition. So I'm saying, like in the generally I can say what is mole. You are supposed to say mole is nothing but it's the number of particles. But when the examiner would be asking, then you are supposed to write amount of substance that contains the same number of particles as in 12.00 grams of carbon 12. That's the definition of mole according to the examiner point of view. And it's only counting, like let's say if I'm saying how much bananas you have, so you will say 12. You are not supposed to write any of the unit. You are not supposed to write any of the unit, because the thing that you are telling to me, I got it. Like in the physics, we generally say that with the magnitude, let's suppose 12 is the magnitude and grams is the unit. So with this, now the thing is completed, like 12 grams of sugar, like I got it. Like if I'm saying 12 sugar, so what do you mean by this? Isn't it? If I'm saying 12 sugar, what do you mean by this? You're not using the unit. Without unit, the thing is incomplete. I cannot understand it. But when I'm saying that I have 12 bananas, so means that like you understood. Okay, so it's mean that unit is not required. With the counting, unit is not required. Itself mole has no unit, but when you will be getting your answers, you are supposed to write mol with your answer so that I can identify that this is the answer of mole. Okay, so by the way, it's nothing but it's the amount of substance. Just like one dozen is equal to 12, one pair is equal to 2. In the same way, one mole is equal to this much particles. This is called Avogadro's constant. There was a scientist named as Avogadro's. He told us that in one mole of a substance, this much particles are present. This is an accurate value, in next classes in A2, we would be discussing this. There would be an experiment in which we would be calculating the whole and soul. Basically, it's the topic of electrolysis. And interestingly, we will be getting the same answer, that is 6.02 times 10 to the power 23. So this number is known as Avogadro's constant, which is represented by Na, Avogadro's number. So you will see the definition of Avogadro's number in your exam. So you are supposed to say it's the number of atoms, molecules, or ions in a mole of a given substance. In a mole of a given substance. Like I mean to say that, let's suppose I'm going to give you sodium. Okay. From the periodic table, if you can see this one, sodium's proton number is 11 and its mass number is 23. Listen carefully. I'm asking, I'm asking how much, how many particles of sodium is present in 1 mole of sodium. I have taken 1 mole of sodium. How many particles are present in 1 mole of sodium, or I can say how many atoms are present in 1 mole of sodium. You know, you are supposed to write 6.02 exponent 23. Let's suppose I am asking in magnesium how many atoms are present. You will say the same thing. Let's suppose I'm asking in copper how many particles are present. You will say the same thing. Let's suppose if I'm asking how many atoms of chlorine are there in 1 mole of chlorine, you will say the same thing. So the thing is that 1 mole of everything, but you must have 1 mole, one. If you will be changing the moles, so the value will change. Of course, if 1 mole of sodium has this much particles, right? So 2 moles of sodium would be having multiplied by 2, isn't it? Multiplied by 6.02 exponent 23. So then the value will be multiple. So always remember the standard thing is that we will be writing down the number of particles in 1 mole. 1 mole of everything. It may be hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium, scandium, everything 1 to 120 in the periodic table. So 1 mole of anything is going to have this much particles. That's why in the definition of Avogadro's number, you can see number of atoms, molecules or ions in a mole of a given sample of a given substance. The given substance may be lithium, the given substance may be calcium, the given substance may be chromium, the given substance may be gold, the given substance may be bromine, the given substance may be fluorine. So in short, in a simple word, if I ask what is Avogadro's constant, you are supposed to write 6.02 multiplied by 10 to the power 23 atoms, molecules or ions. That's it. It's called Avogadro's constant. So basically, Avogadro's number, also known as Avogadro's constant, is the number of particles found in 1 mole of a substance, and that's it. And then numerically, if I can say 1 mole is equal to the relative formula mass. What is this? What is this? Basically, I have to take this from the periodic table. Let's say sodium, chlorine, oxygen, phosphorus, water, sulfuric acid, nitric acid, aluminium sulfate. So, sodium has a mass of 23. So, from the periodic table, chlorine has a mass of 35.5, oxygen has a mass of 16, phosphorus has a mass of 31, then 18, then 98, then 63, then 342 grams. All are equal to 1 mole, 1 mole, 1 mole. Everything when something expressed in terms of grams. So it's equal to how many moles? 1 mole. And how did you get this number? How did you get these numbers? The answer is from the periodic table. How did you get water? Water is H2O. I saw from the periodic table hydrogen is 1. So I have 2 hydrogen atoms. I have multiplied 1 by 2, and then oxygen, the mass is 16, so the total is 18. That's the mass of water. Again I have written 18 grams of water, it's equal to 1 mole. Remember, any mass, I'm saying any means everything. Sodium sulfate, magnesium sulfate, potassium manganate, aluminium, copper, scandium, titanium, vanadium, zinc, hydrogen, bromine, fluorine, chlorine, iodine, any mass that is expressed in grams is equal to 1 mole. Is equal to 1 mole. That's it. So that's why, that's the reason I have taken anything that is equal to One mole, one mole, one mole, one mole, one mole, and that's it. Okay. So first of all, you need to know, how we are supposed to get 98 from this, how we are supposed to get 63 from this, and how we are supposed to get 342 from this. Once I would be getting these numbers, so I would be writing the grams in front of them, and I would be getting the moles, That's it. Okay. So 1 mole is equal to atomic mass of an element, molecular mass of a molecule, formula mass of, let's say. I'm considering that you have studied chemical bonding, you have studied elements, mixtures, and compounds. Okay. I'm going to tell you the difference between atomic mass, molecular mass, and a formula mass. More specifically. Okay. So I want to tell you that if you have sodium metal, if you have sodium metal, lithium, potassium, rubidium, cesium, copper, scandium, titanium, gold, any metal like sodium, like sodium is a metal, like sodium is a metal. So I am supposed to use the term atomic mass. I'm supposed to use the term atomic mass. Hopefully you are getting my point. I'm supposed to use the term atomic mass, isn't it? And if I have compound like this one, H2O, it's a covalent compound. H2SO4 is a covalent compound. Aluminium sulfate is an ionic compound. If you have a covalent compound, you can say this is the molecular mass. And if you have an ionic compound, then you can say this is the formula mass. Are you getting my point? Yes or no? Generally, you can say that this is the molecular mass. Generally, you can say that this is the molecular mass. Are you getting my point, Mariam, Malika? Is that clear?
Yes, sir.
Okay, so anything with expressed in grams is going to be 1 mole of that particular substance. And more specifically, you have to see if you have a single atom metal, so you can say atomic mass. If you have a covalent compound, it would be molecular mass. And if you have an ionic compound, so it's gonna be relative formula mass. Generally, we call all the masses as molecular mass, and that's it. Generally. More specifically, if the examiner would be asking, so then you can specify it. So, like I told you, this one, of course, the same thing. Mole is nothing. Mole is nothing. It's 1 mole, basically the number of particles, just like dozen. Or, or then we have to do some practice related to the calculations of moles. Like, as I told you that 1 mole of any substance contains this much particles, that is 6.02 multiplied by 10 raised to the power 23. Okay. So 1 mole of a substance contains this much particles. So, but remember 1 mole only. Remember 1 mole only. If you are having the different numbers of moles, then the answer would be different. 1 mole of a sample contains this much particles. If you would be having 2 moles, the answer would be different. If you would be having half moles, the answer would be different. If you would be having 4 moles, the answer would be different. Remember. Okay. So that's the reason I am saying if I have this 1 moles of oxygen, so what would be the number of molecule? Particles means molecule, particle means atoms, particle means ions, the same thing. So 1 mole contains this much. If I have 5.2 moles, 1 mole contains this much. If I have 5.2 moles, that's gonna be X. That's gonna be X. So of course, then you have to cross multiply this. You will be getting your answer. The answer is this one, isn't it? Okay. Or why I am going to multiply this by 2? If the examiner would be asking the number of atoms rather than molecules, so oxygen molecule contains two oxygen atoms, then you have to multiply the number with 2. Then you have to multiply the number by 2, because in the molecule of oxygen there are two oxygen atoms. So then we are supposed to multiply this oxygen molecule by 2. That's the reason. So you have to see whether the examiner is asking regarding the number of molecules or he is asking regarding the number of atoms. Okay. What's the answer if I'm going to give you this? Find the molecule of water. Find the number of molecules of 1.26 mole of water. Can you solve it fast?
Sir, so 1.626 into the Avogadro constant? Sir.
What were you saying? What's the answer? Yes.
Sir, should be multiplied into Avogadro constant?
Yeah, basically you have to do in this way, like you can say
Okay.
that one mole contains this much particles. Okay. So how many particles I would be having if I have this one moles? In this way you can solve it, right? So X is equal to what? Like that. That would be your answer, isn't it? It's easy. Okay. So now you can see now you can see this one. I'm again telling you that particle means molecules, atoms, or ions. Particle is a general term. Now they are asking about the number of ions. Now they are asking about the number of ions. Again, the same thing means that they are talking about the number of particles. Okay, so you are not supposed to mix the term. It's a general term which is used for the molecules and atoms or the ions. So again, the criteria would remain the same. 1 mole of ion contains this much ions. So if I have 25 ions, how many moles I would be having? So again, I have to cross multiply this, isn't it? Isn't it? The same thing, the same thing. Nothing is new in this. Nothing is new. Hopefully you are getting my point, what I'm saying. Can you hear
Yes,
me?
sir.
Yeah, okay. So, okay. Okay. Now, This is about the this is about the relationship between the moles and the number of particles. It may be molecule, it may be ions, it may be atoms. Can you solve it? I'm going to give you Find mole of 106.3, 106 ions of chloride. Can you solve it? Yes. Yes. Yes, what's the answer for this one?
Sir, 1 minute.
Mhm.
Sir, so I divided by the Avogadro constant now?
Yeah, so basically the pattern is that if 1 mole is equal to this much ions, if 1 mole is equal to this much ions, and if I have 106 ions, so what would be the number of moles? Then it's going to be X. So X is equal to 106 divided by 6.02 exponent 23, isn't it?
6.02 into 10,000. Yeah,
Yeah. Basically, what I did, I cross multiplied it. That's it.
yeah,
Like the thing is that you need to know when I'm supposed to multiply it, when I'm supposed to divide it. It depends. It depends. Okay. Then what if the gram is given to you? What if the gram is given to you? So that's the formula. Mole is equal to mass over molecular mass or atomic mass or formula mass, depends of course what is given to you, metal, covalent compound or an ionic compound, depends. And also we can find out the mass as well. Mass is equal to Mr. Moles. Mass is equal to molecular mass, that is represented by Mr. So Mr. Moles, if you will be finding out the mass, that's gonna be equal to Mr. Moles, and if you are supposed to find out the moles, it would be equal to mass over Mr. So it depends on the value, what is given and what they are asking. If you can see this question, in this question, they're asking the number of moles and they have given you the mass. Mass can be given in the mass can be expressed in grams, mass can be expressed in kilograms, mass can be expressed in tons. Depends. Okay, all will be the masses. You have to apply the same formula whether you have grams, whether you have kilograms, and whether you have tons. I will be applying the same formula, that is mole is equal to mass over mr. So what's the answer? Of course, you have to first find out the mr of HCl from the periodic table. Of course, hydrogen is 1 and chlorine is 35.5. It's gonna be 1 plus 35.5, that is equal to 36.5. That would be the molecular mass of HCl. Then you have to divide it. You will be getting the answer of moles. Okay? What's the answer? Hmm? What's the answer?
Sir, is it
Yes.
1.02 into 2 raised to 25? Into 10 raised to 25?
See this one? Mass is 3.02. MR is 36.5. So I have applied this one formula. Mole is equal to mass over MR. The mass is given, that is 3.02. MR of HCl is 36.5. I have multiplied these two values. I got 0.08. Are you getting my point?
Yes, sir.
Hmm? Yeah, okay. And what about this one? If I would be asking the mass, not the moles, then what you would be doing? Fast, 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 fast.
Sir, can you repeat it? Repeat the
I'm
question.
asking the mass. I have given you the moles. How you would be doing this
Yeah.
question? Mhm.
A number of moles into Avogadro constant.
No, no,
Sorry,
no, no, no,
molar
no,
mass.
no. There is no Avogadro's constant.
Yeah, molar
They're
mass.
asking, yeah, Mr. Moles.
So the mole into MR. Sir, is that right? Yeah.
Okay. Did you get the same answer?
Yes, sir. You have to multiply moles into MR.
And MR of HCl is 36.5, right?
Yeah. Yeah.
Okay, good one. Can you do this one? In which I have given you the moles of C6H12O6 and I'm asking the mass of C6H12O6.
Okay, sir. I'll try. Sir, is that 1 mole of HC6H12O6? 1 mole or 0.1?
0.1 mole of C6H12O6. First of all, you have to find out the
Yeah,
molecular mass of C6H12O6. That is
this
180.
one.
That is 180.
180
Yeah, that's the MR. So then you will be
into
applying the
zero point
formula,
0.1.
that is mole is equal to mass over MR. Then you have to find out the mass. Mass is equal to MR multiplied by moles. I have given you zero point 0.1 mole. You have to multiply this with the MR, that is 180. So you will be getting 1.8, I think so, or 18.0. I think. What's the answer?
It's 18.
18.0.
Yeah.
Yeah, that's the answer of, that's the mass in grams. In this way, you can calculate the mass in grams if the moles are given to you. If the mass is given to you, then the criteria is something else. Then you have to divide it. It depends on the question. It depends on the value, what the value is given to you. Okay. Okay. So
Okay.
first of all, you have to see whether the number of particles are given and whether the mass is given to you. So, so far, I told you the two formulae. The first one is how we would be calculating the moles if the mass is given, and how we would be calculating the mass if the moles are given, and how we would be calculating the moles if the number of particles are given, and how we will be calculating the number of particles if the moles are given. So you have the two relations. You can use it after looking at the values in the question, what the value is given to you, then you have to decide which formula I'm supposed to use. Are you getting my point? Okay.
Yeah.
Yeah, okay. I'm going to give you some questions, then you have to tell me the answers. Okay.